guys. Yeah, sorry about that. I got my lectures mixed up, and I thought I was teaching my further maths group now, but I wasn't. I was teaching you guys, so that's why we're 10 minutes late starting. But I do apologise. Yeah. So as we discussed last time, I think the plan for today is to go over vectors. I was going to do area integration, but there are videos on that with my other groups from Wednesday, I think. So if you want to do area integration, you can look through those videos at some point, but yeah, today I'm going to do vectors, and then Thursday we'll have a look at parametrics, and then we'll finish up with separation of variables on Friday. Cool, so if you guys could type names, some of you have already. So we've got Sam H, we've got Sam Stevens, Kezia, Regan, and Frank. Yeah, cool. Anybody else there? If you are, please comment or send me a message on Teams. All right. So, yeah, you guys will be the first group I've done vectors with, so let's get started. So, I would say the key part of vectors is to sketch. So, direction, well, direction and sketching. So, direction. If you can sketch it, and if you get the directions right, there's not a lot you can do wrong. I've had a few emails as well about assignment 30, and I think one of the skills checks as well. Skills check 28 for the answers wrong. And assignment 30, I think Dan and Grace have both emailed me about that. Yeah, so there is a mistake in that. I will update that at some point, but yeah, so don't worry too much about that one. Casper, where are you? Cool, Casper, you are swapped in. Alright, so yeah, as long as you get your direction and your sketches right, then you can normally do pretty well with vectors. So what I mean by that, if we have OA equals 3 minus 2, OB equals 1 minus 8, two vectors, I can sketch them wherever I like. It doesn't matter. Should we make it, yes, make it 3D. So it's clearer when it's 3D because obviously you can't sketch 3D vectors. So I'm just going to do a sketch of I and j, or x and y. I'm going to put A here, put B here. Completely, you could say the sketch is wrong, but because we're talking about vectors, all that matters is the origin to A is this vector, and the origin to B is this vector. If I wanted to work out the vector A to B, I'm going to go from A back to B, sorry, from A back to O, and then up to B. So I'm going to do AB is minus OA plus OB. And if we do that, 3 minus 2, 0, plus 1 minus 8, 2, well, we need to do minus OA. We're going to get AB will be minus 3 plus 1 minus 2. 2 plus minus 8, so that's going to be minus 6. And 0 plus 2 is going to be 2. So 2, 6. 2 minus 2 minus 6, 2 would be the vector A to B. Okay, well, if we had, let's redraw this, but let's stay with this situation I've got here. It's going to write A and B at the top, a bit smaller. So so far we found AB. So if I do my sketch again. So you found O to A, found O to B, and AB. Okay, right, we could have, if we had another point, let's put a point C. So maybe C is part way along this line. We could say A to C equals lambda A to B. So in other words, they're parallel. C is on the line, therefore they have to be parallel. So AC is part of AB. And yeah, we could try and find it. We could say if C divides AB in the ratio 3:4, we could say that AC is going to be 3/7 of AB. We could use that to find out what C is. So we could say, well, AC is 3/7 of -2 minus 6/2. We could then use that to try and find OC. So OC be OA plus AC. So we're going from here to here, and that journey is the same as going directly to C. So as long as you've got a sketch, as long as your directions are consistent, vectors should never be too bad. And we always use lambda or mu if we've got parallel vectors. That's basically the factor of it's the scalar. It's the scalar that scales a vector to be equal to another. Okay, one last thing is if you've got I component, if vectors are equal, so if vectors are equal, so e.g. 5, 2 equals lambda. Don't know if this is going to work. 2 k. There. If these vectors are equal, we can look at their I components separately, and we can look at the J components separately. That's all right, Hannah. I'll swap you in now. So if vectors are equal, we can equate their I and J components. So if these two vectors are indeed equal, we can say 5 equals 2 lambda and 2 equals k lambda. So we can find lambda. So lambda would be 5 over 2. So then we could say 2 equals k times 5 over 2. So 2 is 2.5 k. So k is 2 over 2.5. So we can equate the coefficients separately if vectors are equal. Okay, so we're going to try some questions. That was a very quick kind of summary of vectors. So I got some past paper questions and I also found some difficult book questions. So I think we'll start with the past paper ones, which are slightly easier. So you got a 6-mark question. It shouldn't be too difficult. Does that appear on the screen? Yeah. So could you guys this one, 6 marks. I will give you slightly longer, 7 minutes. I know students do find these quite difficult. So 7 minutes starting Cool. Have you guys finished, or do you want some more time? I know there's a few answers for part A there that look pretty good. Do you want a little bit longer to do part B and part C, or not? Shall we just go through it? Yeah, go on then. Right, so point, let's draw some stuff. OC is 2 lots of OA. Okay, so straight away, it's going to shrink that a little bit, just so I can fit in what they're saying. So OC is 2 lots of OA. So OC, C must be up here somewhere. Nope. I'm just going to redraw this, I think, because it's annoying. So we got the C must be up there. Okay. We know M is the midpoint of AB, so M can go here. And we know a line cuts OB from C to N, cuts at the point N. Okay, OA is A and OB is B, find C to M. So C to M, we could go C to A to B. So let's write out a plan for this. CM equals CA plus half AB. C to A, well, if OC is 2 lots of OA, then CA is going to be minus A. So we get minus A. And half AB, AB is going to be B minus A, so plus half B take A. We need to simplify that though, so we got A, take a half A, it's going to be minus 3 over 2A plus half B, like you guys said in the comment section. Good job. Okay, we now need to find O to N. Okay, this is a little bit more difficult. So ON, okay, we need to find 2 different routes to get to N. We probably want to look at the answer so we can get an idea of what's going on. So we've said we got 2. So if we look at the first kind of bit here, we've got 2A. So 2A would take us up to C. So we've got OC here by the looks of it. Then we're taking away 3 over 2A. Okay, yeah, that's what we're doing. Alright, so their route here, basically looking at it, you can kind of spot what they're doing. They're saying go from O to C, and then go C, a bit of that direction there. So O to N equals O to C plus lambda C to M, because C to N is on the same line as C to N. So we know OC is 2A, so ON is 2A plus lambda CM, and CM is minus 3 over 2A plus half B. If we simplify that, we end up with what they're after. Okay, hence prove that ON to NB is in the 2 to 1 ratio. So we're going to find 2 different routes, like I said, to N. So one of my routes to N is the one they've kind of made us find in part B. The other route we can take to N is just to go mu OB. So we also know ON is mu OB. And mu OB is just going to be mu B. So we're going to set mu B equal to ON, and we're trying to find out what mu actually is. And we're hoping mu should be 2/3. Right, so we're going to say 2 minus 3 over 2 lambda A plus half lambda B equals mu B. So we can ignore all of the A bits completely because there's no A terms. Actually, that might be an easy way. There's two ways you could do both and check. So we can say, because in our second equation there is no A, we can say all this stuff must equal 0. So 2 minus 3 over 2 lambda must equal 0. So 3 over 2 lambda equals 2. So lambda is 4/3. That doesn't really help us. All it tells us is that C to M is 4/3 of C to M. So you've got like a 3 to... No, that's not right. Yeah, 3-to-1 ratio for CMN. That's not what it's asking us though. It's asking us to find mu, basically. So I'm going to use the other bit here and say half lambda equals mu. So half of lambda is mu. Lambda will be found as 4/3, so half of 4/3 is mu. So mu is 2/3. Because mu is 2/3 of OB, so ON equals 2/3 OB, therefore 2-to-1 ratio. Right, has anybody got any questions about that? So good sketch. Directions, be careful your directions, and we're setting bits equal if they're parallel or equal vectors. Right, I'll put the next one up. If you do have any questions, please don't hesitate to ask. Cool. Next one should be a little bit easier, I think. I think we might have looked at this one before. Maybe. Anyway, give it a go. 5 marks, 5 minutes. See how you do. Cool. 1 more minute. Yuki. Cool. All right. Okay, geometrically, what does it mean? No one's commented. What does it mean if A plus B is the same size as A plus B? Any others? All right, we'll come back to that. Have a think. I'd like to see some things as to what you guys reckon. So 2 different vectors are such that mod m is 3 and mod m minus n is 6. Okay, so we can try and draw this. The angle between m and n is 30. So if I put m here, and n here, the angle between these two, 30. We know that m is size 3. We know m take n is size 6. Well, m take n, if we have a think about what that looks like, if we started at n, we went minus n plus m, which is what we got, basically telling us this size, this is m minus n, that is length 6. So it wants us to find the angle between m and m minus n. So it wants us to find this angle here. Alright, I'll have a look at those answers in a minute, guys. We'll go back to it. So I believe we want to use the sine rule followed by the cosine rule. So if I redraw this triangle, we know this side is 6, this side is 3, this side is what we want, this is x, this side is 30. So we can use the sine rule to find the other angle, and then we can use the angles in the triangle to find x. So we're going to say 6 over sine 30 equals 3 over sine theta. So sine theta is half sine 30, right? Yeah, half sine 30. Yeah. So sine 30, I believe, is a half. So half of a half is a quarter. So we're looking for sine theta is a quarter. So if I arc sine a quarter, we get that I'm in radians. So let's get rid of that. Where's degrees? Cool. We get 14.48 degrees. Okay. I want to find the other angle, so we're going to do 180. Look at the top. Take 14.48. Take 30. Which gives me 135.52. One decimal place, so 135.5 degrees is my answer. Cool. All right, let's go back to part A then. So what does that mean? What have you guys said? The magnitude of the two vectors added is equal to the sum of the magnitude separately. Yeah, all you've done, Dan, is said in words what that statement says. You haven't explained what it signifies. So, no marks. Sam says the magnitude of the result of the sum is equal to the sum of vector A and the magnitude of vector B. No, you've said the same thing as well. So both of you have just said in words what those symbols mean. You haven't explained what they signify. Right. So let's do a sketch, because sketches are always good. I know I can. Okay. So here's some axes. I'm going to put, well, let's do A plus B. Well, actually, no, if I draw A there, if we put B somewhere as well, so if A's this way, I'm going to put B as something slightly more horizontal. So if I wanted to draw A plus B, don't think there is, because you want to try and find an angle, Sam, so I don't think that'll help you. Yeah, if you want to draw A plus B, we can literally just tag B onto A. So I'm going to just put B on there. Cool. Or I could tag, tag it on there. So A plus B is going to be this line down the middle, basically, up to here. That is A plus B. Now, if the size of A plus B is equal to the size of A plus the size of B, the only time that can happen, see if you guys can work it out from my sketch. Geometrically, what's the significance if A plus B is the size of A plus B is equal to the size of A plus the size of B? What does it mean? Nope. I mean, I've drawn a parallelogram, but that's not what it signifies. So all I've drawn is, if I get rid of this, let's draw it again. I'd like you guys to get this. So here's A, here's B, what does it mean if A plus B, which is this line here, is the size of this is equal to the size of B plus the size of A? What does that mean? When does that happen? Nope, not A and B are equal. Okay, let's no, no, no. Okay, let's try and make it hard. Let's try and make it easier, not harder. Let's say that A has a size of 3 and B has a size of 4. Would you be surprised if A plus B equaled A plus B? In this sketch I've drawn, if B is 4, if B is 4 and A is 3, would you be surprised if A plus B was 7? For it to equal 7, for this side to equal 7 on this triangle, how can that happen? There is one situation where that's possible. What's significant about that state? About that case? Any ideas? Nope. If they're right angles, it'd be 5. Because if it was right angles, you'd have 3, 4, which would give you a 3, 4, 5 triangles. That side would be 5. So they're not right angles. It's just a sketch. It shouldn't really matter. When is that possible? I'll tell you guys in a sec. I just want to see if anybody can get it. Yes, when they're parallel. It's the only time, because it has to be a line, the only time where A plus B will be 7 is when they're in a straight line. Collinear or parallel, yep, same thing. So explain geometrically significance, they are parallel. That's the only time where A plus B will equal the same as mod A plus mod B. Because otherwise you'd have stuff like this, it'd have to be less. Normally it'd be less. The only time it's the same is if they're in a line. Thanks, Dan. You got us past that moment. Okay, let's try some more. Oh, I only got 40 minutes left. Okay, let's see what else we got. This looks nice and easy. So 4 marks. I don't think it'll take you that long. See how you guys get on with this one. 4 minutes. Start in now. All right. So, point A, okay, yeah, not too bad this one. So vector AB is going to be B take A. So 8, 3 minus 3 minus 7. So we get 5, 10 there. Mod AB, 5 squared plus 10 squared. It's going to be root 125, which is 5. Root 5. Cool, nicely done, Dan. Yeah, easy peasy. Next one. Got on with it. That's annoying. This one is on 2 separate pages. Let's do it anyway. I'll drag and drop them in. So that is 5 marks worth, so 5 minutes on this one. See how you get on. Should be pretty straightforward. We'll try and get some harder ones done in a sec. So 5 minutes starting from Cool. All right, let's do it. Again, pretty quick this one. Well done, you guys answering it nice and fast. So relative to the origin, we got point A there. We got point B there. And we got point C somewhere else. And we know A to B is the same as B to D. So D is probably over here. So if AB equals BD, they must be the same length and the same direction. So to find position of D, let's go OA and then plus 2D. So the plan there is OD equals OA plus 2AB. So that's going to be 2, 3 minus 4 plus 2 lots of AB is going to be B take A. So B take A, AB even. It's going to be 4 take 2 is 2, minus 2 take 3 is minus 5, and 3 minus 4 is 7. So 2 lots of 2 minus 5 is 7. So we get 2 plus, oh, let's just do it. 2 plus 4 is going to be 6. 3 minus 10 is minus 7. And minus 4 plus 14 is going to be 10. So 6 minus 7, 10. I might have made a mistake because you guys have got something else to me there. B take 8, minus 2, take 3 is minus 5. Minus 10. 3 plus minus 10. Minus 7. We disagree. Why do we disagree? Minus 2, take 3. O to A plus A to B plus A to B. I can't see where you guys got the 3 from. Can you, yeah, cool. I think Kezia and Dan, you two are wrong. But yeah, Sam, nice. Cool. Okay, given AC is 4. Alright, AC, where's C? Okay. Find the value of A. Okay then. So we need to do C take A, which will be AC. So C take A is going to be A minus 2, 2, and minus 2 minus 4 is going to be 2. So we get that as the size of 4. So A minus 2 squared plus 4 plus 4, all square rooted is 4. So if I square both sides, we're going to get 16 equals 8 plus A take 2 all squared. So I'm going to take 8 from each side to get 8 equals A minus 2 squared. Square root both sides, we get root 8, which is 2 root 2 is A minus 2. A is less than 0, A is negative, so we're going to get A equals 2 minus 2 root 2. I think that's it. See what you guys got. I think that's it. Comment, let me know if it's not, but I'm pretty sure that's the answer. Okay, what's left? One more question here, and then we'll move on to the book ones. Yeah, that sounds good to me. Actually, no, let's not. That's so easy. No, let's not bother. Straight to the textbook stuff. Okay, random order. What are we doing first? No, I think we'll leave that one. I'd rather do another one if we've only got 20 minutes. Yeah, let's do this. We might have done this before in lectures, but see how you guys can do. 18. Let's try for 8 minutes. If you need more time, let me know. See if you can prove that those two diagonals bisect. It's 8 minutes starting from How's that? Do you guys need a bit more time, or do you want to go through it? I guess you can't really write your workings because it's a proof, so... do you guys want longer, or do you want me to start doing it? Let's do it, I guess. Cool. Okay, so the idea is show OF and AG bisect. There's OF, there's AG. So we want to show that they meet and they meet halfway between. I'm going to call the intersection X, so it's a little bit easier to kind of deal with. So we're going to find two different ways to get to X using OG and using OF. So we'll say OX is lambda OF, and we can also say OX is OA plus mu AG. So OF, well, to go from O to F, I can go basically using all the vectors we have. We can go O to A to D, D to F. So OX is lambda A plus B plus C. The first root. The other root then, we're going to go O to X is O to A, which is A, plus mu A to G. Well, A to G is minus A plus B plus C. So B plus C take A. Now, those roots should be equal if those two lines meet, if they bisect. So I can set those equal to each other. So I'm going to say lambda A plus B plus C equals A plus mu B plus C minus A. So all we need to do now is solve bits simultaneously. So I'm going to look at all the A bits. So for A we get lambda is 1 minus mu. All the B bits we get lambda equals mu. All the C bits we also get lambda equals mu. So I'm going to choose two of these to solve simultaneously. So these two, so we can say mu is 1 minus mu. So therefore 2 mu is 1. Therefore mu is a half. Therefore lambda is a half. Therefore bisects each line. Cool. There you go. Right, 10 minutes left. Let us try one more question. I don't know if we'll finish this, but we may as well start it. That's what we just did. Cool. All right, 9. Nah, we're not going to finish it. If you guys start this now, if you need any hints, I'll still be here, so ask me if you need any hints. But we will start going through this one on Thursday. So D start here. All right, 10 minutes starts now, but 10 minutes starts now. I'll be here, but if we'll go through it next time. So if you need help, comment. Otherwise, I will see you guys on Thursday.